Don't forget to subscribe and ring that bell.
Hey man, what's up? And welcome back, or welcome for the first time, as we are going to continue the 2008 AP Calculus AB practice exam that College Board put out years ago. We are going to start with the short answer problems with free response question number 1. And hey man, yeah. We could use a graphing calculator. And speaking of graphing calculators, the set I use for my class that I highly recommend, the TI-84 Plus CE, the color edition, just looks so much more nice and crisp. And obviously the different colors are really nice when you're graphing multiple functions. They come in a whole slew of colors. I put some links in the description below if you're interested in them. I own one personally, not only for my class, but my own personal one. And my favorite color is green, so I got that mint green. So minty, so purty. Let's start. Number 1 reads, the rate at which raw sewage enters a treatment tank is given by E of t equals 850 plus 715 cosine of pi t squared over 9 gallons per hour. All right, that is a rate. For the values of t between 0 and 4 inclusive, treated sewage is removed from the tank at a constant rate of 645 gallons per hour. The treatment tank is empty at time 0. All right, a lot of information. 1A, how many gallons of sewage enter the treatment tank during the time interval between 0 and 4? Okay, this is a relatively straightforward and easy problem to do because we have that calculator, all right? How many gallons of sewage enter the treatment tank between times 0 and 4? We have a rate of sewage entering. Okay, that rate is in gallons per, is that hour? Yeah, per hour. Okay, if I wanted the derivative of that, it would be gallons per hour squared. However, they just want how many gallons, which means I'm going backward, which means I need to integrate this rate to get my quantity. All right, so I'm going to integrate my equation E of t dt from my bounds, or the hours, 0 to 4, and I'm going to put that right in my wonderful TI-84 Plus color edition right here. Viewed, attached LCD. Let's get this here, put this here, turn this bad boy on. And in case you don't know, now you know, I'm going to math number 9. All right, my bounds are going to be from 0 to 4. Yep, not 04, but delete that, from 0 to 4. And the equation I'm going to use is the one given to me, 850 plus 715 cosine alpha y equals enter, because I want that fraction. And it is going to be pi times x squared all over 9. Now let's make absolutely sure we have the same number of closed parentheses as open. We do. And let us not forget our dummy variable. And if we do that correct, we get 3981.022. 3981.022. Round your answer to the nearest gallon. So that would be 3,981 gallons between the hours 0 and 4. Sewage entering the treatment tank. 1B. For t values between 0 and 4 inclusive, at what time? It looks like we're going to have to find some sort of t value. Okay? At what time is the amount of sewage in the treatment tank the greatest? To the nearest gallon, what is the maximum amount of sewage in that tank? Justify your answer. All right. So, All right. What I'm going to do is I'm going to graph E of T. That's where I'm, sewage is entering. So I'm gaining more raw sewage at this rate. Okay. I'm also going to graph, what was it in the previous problem? I'm going to go back here for 1 second. Okay. I'm also going to graph this rate, 645. I guess removed, I just call that R of T for removed, because it is a constant, 645 gallons per hour, okay? So R of T, which is being removed, is just 645. That's it. It's a constant. And that's where it's being removed, the sewage. We'll do this in green. This was 850 plus 715 cosine of pi t squared over 9. So I'm going to graph both of these. And I'm going to use, because it's the color edition, a green and red graph so I can better visualize. And that's why I love the color edition. I'm not trying to pawn it off on you. I just love it. I love it so much. Here we go. My green is 850 plus 715 cosine. Let's get that fraction up there, of pi times x squared over 9. Now, I know that there are a total of 9,000. I'm not even sure my window what it needs to be. But the red, okay, it's leaving at a constant 645. So my function for removing sewage is just a constant. It is 645. Now, I know I at least got to have 645 on the y-axis because that's where my red function is, my y2. So for my windows, all right, now they said between the times 0 and 4. You see that right there, right above the calculator? So my x-axis, I really only want to go from 0 to 4 because x is my time. But my y's, I don't know, let's go from 0 to maybe 1,000 by 100 because I don't want to see 1,000 tick marks. Okay, that's the red. That's the removed one. Sewage is coming out at that. And where's my green one? Where are you, buddy? There you are. Okay, it's above. Oh, Lord. It is way above. I got to go higher. Higher. Okay. So let's change this window, and let's go to 2,000 by 200s. Okay, let's graph the same thing. There's my 645. I think we're going to get it all here in the window now. There we go. Oh, it's beautiful. So let's really analyze what we're looking at. Okay, let's analyze what we're looking at right now. All right. Here you go. Let me put this out here. So what do I really have? What is this graph telling me? Okay. First of all, at what time is the amount of the sewage in the treatment the greatest? The green line or a green function. This right here that I'm highlighting, okay? That's the rate at which sewage is entering this treatment tank. And this red one, I'll do this in red. Okay, that's the rate at which it's leaving. As long as the rate, the green line of sewage entering is greater or higher up on the y-axis than the red, I'm always gaining more sewage. And what do I mean? Here, at this point, I'm gaining more sewage than I'm losing, because I'm only losing at this rate. So as long as that green line is above, all this area I'm shading in, the green line is always bigger than the red line. So right until I hit this spot, I'm constantly gaining more because my green line, or E of T, is bigger values, okay? Now, between this point and this intersection point, you'll notice I'm losing more than I'm gaining, all right? But then let's look after that. My end point, where time is 4, okay, I'm gaining again. My green line is bigger. Okay, so I'm once again gaining sewage. Okay, and I simply can tell because the green line is higher up than the red line. Okay? If I want to know when I have the greatest amount of sewage, I need to know what value this is. Because all of this in here, I'm gaining more sewage than I'm losing. So I keep on gaining more and more until I hit this point. Okay, let's find that intersection point. Let's find that time. That time is approximately what right there? Okay, let's go back to our calculator. So I'm going to hit second trace, and I'm going to pick intersect. And I'm going to move close to my little spider dude right there and hit enter 3 times. That's a value of, let's call that 2.309. It's right down here. Okay, 2.309. So I go back to my graph, and that's 2.309. All right, so from time 0 to hour, 2.309, I have been gaining more and more and more sewage. So that might be the time where I have the most. Because after that, I'm losing sewage. I'm not going to have more. I'm going to lose. I'm going to have less. But then I gain again. Okay? So what I should do is I'm going to check the amount of sewage I have here at this point because I was gaining more. But then I'm also going to check this end point because, look, I'm gaining more again. So I got to figure out the amounts at time 4 and the amounts at time 2.309 and see which one is bigger. So just like part 1A, how do I figure out gallons? Okay, how do I figure out gallons if I have this rate? I integrate. Okay, I integrate. And that's exactly what I'm going to do here. And I'm going to use those values of time. All right, so let's do this. Let's say we're going to integrate starting at time 0 right until that first intersection point, which is 2.309. I'm going to take E of t and subtract, I'll call that R of t, which is 645. I can literally write 645 here if I want, dt. And I'm going to see, and that's going to give me the gallons I have in the tank at that moment, 2.309. All right? A lot of explanation here. A lot of explanation, but I want to make sure you get it. So let's take this thing right here, and I'm going to manipulate this a little bit so I don't have to retype it out, but maybe it would have just been easier if I retyped it. And first thing I'm going to do is I'm going to change my bounds. 2.309. And now I'm going to put insert my E of t in its own set of parentheses. And now I'm going to subtract the R of t, which is a 645. And I'm going to hit enter. And I get 1,637. Okay, 1,637.17 gallons. All right. 1,637.17. All right, well, let's see how much I have in at time 4. Because even though I lose some sewage, I start to gain sewage again closer to the end. All right? After this time 2.309, this number starts going down because of this value here. Okay? Because that is below the, that's a negative, okay? Negative value, okay? Because my amount of sewage leaving is greater than gaining. Right? So let's check at time 4. So I'm going to do the same thing that I did above, except I'm going to do this integration from 0 to 4 of E of t minus 645 dt. And this is going to be even easier to do in the calculator because I just copy the integral I have above, and I literally just got to change the bound. So now I go all the way back, and I make that upper bound 4. Delete, 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 delete. Make that 4. And I have 1,401. Okay, call that 1,401. 1,401 point, was it 022? We'll just call it 0.02. Okay, so at what time is the amount of sewage the greatest? Well, I think we answer that. It's right here at this time, 2.309. And what is that maximum amount? It's right here. So let's actually just state that. Justifying your answer is this math work. So at time 2.309 hours, the max amount of sewage is 1,637 approximately. That's gallons. There you go. All right. That was a lot of discussion and explanation about what we were doing. But it's there, and we're done, and we did a bang-up job on that. 1C. For time between 0 and 4, the cost of treating raw sewage that enters the tank, okay, at time t is 0.15 minus 0.02 t dollars per gallon. So to the nearest dollar, okay, to the nearest dollar, what is the total cost of treating all the sewage that enters the tank during the time interval? All right, let's we started 1A with something easy we put right in the calculator. 1B, we had some explaining to do. We should check some values. We had to look at some graphs. That was more detailed. C is also easy like 1A was. All right? So let me explain. How do I figure out the cost? Okay? The cost is I take a look here. The cost of treating raw sewage that enters a tank at time t is, it's this value. That's dollars per gallon. Okay? So how do I figure out my gallons entering in? Well, that's E of T. That's my gallons entering in. That's the rate. I multiply that times my cost per gallon, which is 0.15 minus 0.02 T. So that looks like garbage. I expect better for myself, so I'm going to rewrite that. Okay? 0.15 minus 0.02 T. And I multiply that, and I integrate that whole thing. This expression here would give me costs. And I integrate that from 0 to 4 to add up all that cost. Okay, I add up all that cost. All right? And why do I have to include this in here? Because the cost will change depending on the time. And I want to add up all the costs for all that time from 0 to 4. All right? So let's go ahead and let's put this in our calculator. Let's go math 9 from 0 to 4 of the cost, which is 0.15 minus 0.02x. Okay, that right there, that first parenthesis is the cost, times E of T. And that's another parenthesis, 850 plus 715 cosine alpha y equals enter of pi x squared over 9. Let's close. Ooh, the 9 did not go in the bottom. 9. Let's close that parenthesis for the cosine function. Let's close a parenthesis for E of T. All right. And put our dummy variable there. $474.32. So that's approximately $474.32 to the nearest dollar. 474 bucks for 4 hours. That's the cost of treating the raw sewage. Hey, we're done. That was easy. That was quick. That was 18 to 19 minutes. You, kid, you're going places. You know where you're going? It's that beautiful city number 5, because you're going to get a 5 on this calculus exam. I'll see you for free response question number 2.
Don't forget to subscribe and ring that bell.